Hello everyone, welcome all to Physics with Astronautics. So in this video we will discuss about some basic formula of special theory of relativity which will help you with the exam of IIT JAM, CSIR NET, JEST and many more MSc entrances for physics paper. So let's begin and let's started with this formulas like Lorentz transformation, that is we can write it as x is equal to ax plus bt, where a is 1 by 1 minus b square by c square root over, and b is equal to minus b by root over of 1 minus b square by c square. Then yx equal to y, zx equal to z, and tdx equal to dx plus ft, where d is equal to minus b by c square root over of 1 minus b square by c square, and f equal to 1 by root over of 1 minus b square by c square. And this is happened when the particle is moving in x direction. Then uh, we can write it as x is equal to x minus bt by 1 minus b square by c square root over yx equal to y, zx equal to z, and tdx equal to t minus xb by c square whole divided by root over of 1 minus b square by c square. And here is our inverse Lorentz transformation. And here x equal to x plus bt whole divided by 1 minus b square by c square, y equal to y dex, and z equal to z dex. And here time t is equal to t dex plus xp by c square root over whole divided by root over of 1 minus b square by c square. And we can consider that gamma is equal to 1 by root over of 1 minus b square by c square, and here beta is equal to b by c. So again a basic formula is gamma square minus gamma square beta square will be 1. Then xx square plus yx square plus zx square minus c square tx square is equal to x square plus y square plus z square minus c square t square. So let's come to the time dilation. And here the delta t dex, that is equal to t2 dex minus t1 dex, will be delta t minus del xb by c square whole divided by root over of 1 minus b square by c square. And for proper time interval, that is if two events are occupying at same places, then we can consider it that delta x will be 0. So our delta t dex will be t2 dex minus t1 dex is equal to delta t whole divided by 1 minus b square by c square root over, that is equal to gamma delta t, where gamma is equal to 1 by root over of 1 minus b square by c square. And again, for simultaneous event, that is if two events occurs at same time, then we can write delta t is equal to 0. So our delta t dex will be t2 dex minus t1 dex is equal to minus delta x b by c square whole divided by root over of 1 minus b square by c square, that is equal to gamma into minus delta x b by c square. Then here is our length contraction. So here L is equal to L naught root over of 1 minus b square by c square. Here L naught is equal to x2 dex minus x1 dex, that is the proper length. So if a rod moving with some angle, then we can write it as Lx will be L naught x root over of 1 minus b square by c square, that is uh, L naught x is equal to L naught cos theta, we can write, and here Ly is equal to L naught y, that is equal to L naught sin theta. So here we can write tan theta is equal to L naught y by L naught x. These are the proper length, and tan theta dex will be Ly by Lx, that is equal to L naught y by, we can write Lx as L naught x root over of 1 minus b square by c square. So this will be gamma tan theta. And again we can write the area as a naught root over of 1 minus b square by c square, that is equal to A naught by gamma, because we do know that gamma is equal to 1 by root over of 1 minus b square by c square. And again, volume can also be written as B equal to B naught root over of 1 minus B square by C square, that is equal to B equal to B naught by gamma. Then here is our velocity addition. So we can write Ux x is equal to Ux minus B whole divided by 1 minus Ux B by C square. So here if the body is moving in x direction, and here uy x can be written as uy root over of 1 minus b square by c square whole divided by 1 minus bux by c square. And again similarly uz also can be written, uzx can be written as uz root over of 1 minus b square by c square whole divided by 1 minus bux by c square. So similarly we can write the inverse Lorentz transformation for velocity addition. So here our ux can be ux x plus b by 1 plus bux by c square. Uy will be ux by root over of 1 minus b square by c square whole divided by 1 plus bux by c square. And also uz is equal to uzx whole root over of 1 minus b square by c square whole divided by 1 plus bux by c square. So let's come to our relativistic mass. And mass can be written as gamma m naught, where m naught is the rest mass, and gamma can be written as 1 by root over of 1 minus b square by c square. And also the relativistic energy can be written as E equal to mc square, that is we can write it as gamma m naught c square. So our kinetic energy will be gamma minus 1 m naught c square. Also E square is equal to p square c square plus m naught square c4. Here p is the relativistic momentum and E is the total energy. And the relativistic momentum can be written as p is equal to gamma m naught v. Uh, this is the de Broglie wavelength, that is for relativistic case. Lambda can be written as hc by root over of k into uh, k plus 2 m naught c square. So our relativistic force where the velocity is perpendicular to the acceleration can be written as F is equal to gamma m naught a. Here a is the acceleration, and if the velocity parallel to the acceleration, then F can be written as gamma cube m naught a. And here is our relativistic Doppler effect, where Edex can be written as gamma E minus PV, and Pdex can be written as gamma P minus EV by C square. Also, omega dex can be written as gamma omega minus kv, and k dex can be written as gamma k minus omega v by c square. Here k is the wave vector and omega is the angular frequency. Also, we can written for inverse law, that is omega is equal to gamma omega dex plus k dex p, and k equal to gamma k dex plus omega dex p by c square. Also, the omega can be written as omega dex root over of c minus b by c plus b. So for separation, we can write nu is equal to nu dex c minus b by c plus b root over, and for approach, we can write nu equal to nu dex root over of c plus b by c minus b. And here are the some formulas of black body radiation. Uh, so let's begin. R plus T plus A is equal to 1. Here R is the reflective power, T is the transmittive power, and A is the absorptive power. So let's come to the Kirchhoff's law, that is E is proportional to A. For perfect black body, A is equal to 1, that is this is perfectly absorb the black body radiation. And also E lambda by A lambda is equal to dq by d lambda. And here E lambda is the energy emitted per unit area per unit time in a particular wavelength. So let's come to the Wind's displacement law, that said that lambda max into temperature is constant. Then Stefan Boltzmann's law, that is dq by dt is equal to sigma 8 into t to the power 4, where sigma is the Stefan's constant. Then our total energy can be written as integration over E lambda d lambda. And here E lambda is the spectral energy density. Then the Wind's distribution law. that is E lambda d lambda is equal to A lambda to the power minus 5 e to the power minus A lambda t d lambda. Uh, so there is no theoretical basis. So for higher temperature, this formula is not valid. Then comes to the Rayleigh's law. So here u nu d nu is equal to 8 pi nu square kt by c cube d nu. Again, we know that from the Planck's theory, that is average energy can be written as h nu by e to the power h nu by kt minus 1. So here from here, I mean, comparing these both equation and solve, we can found that E can be written as 4 by c sigma T4, where sigma is the Stephan's constant, which value is 5.67 into 10 to the power minus 8. And also sigma can be written as 2 pi to the power 5 k to the power 4 whole divided by 15 h cube c square. And also the intensity can be written as c by 4 E, and we can say that I is equal to sigma T4. So intensity is proportional to temperature to the power 4. So here are some basic formula upon STR and blackbody radiation. I hope you all enjoy this session. So for more videos, please do like, share and subscribe. Thank you.